Okay, so let's take a look at our prerequisite review. I'm going to break this up into a bunch of smaller videos, and I'm going to just address the first two questions on this one. So let's just jump into that and see how fast we can get through it. So I actually made a mistake earlier, so that's why I'm redoing this video here. So you'll see my answers are already written down. But when you look for the distance formula, one thing you want to remember is that when you're finding the distance between 2 points, then really an easy way of looking at it, if I have these 2 points here and here, I really want to know how far x moved and how far y moved. And then, of course, we can use the Pythagorean theorem to find that missing side. So I could do delta x squared plus delta y squared equals c squared. So when I look at these problems, the first thing I do is I say, well, it looks to me like x moved by a total of positive 7 and y moved by a total of positive 4. So that's what I have, is I have 7 squared plus 4 squared. So that's 49 and 16, which of course makes root 65, okay? So when we look at that idea, we can be very, very quick about that, and it's not too bad. Now, when it comes to midpoint, there's a simple little formula that we can utilize. It's sitting right here. You add the two x values and you divide by 2, and then you add the two y values and divide by 2. So negative 3 plus 4 is going to be 1. So 1/2. 4 plus 8 is 12. We cut it in half, we get 6. It's a very simple formula, but we really do need to remember how to use it, because just because it's easy doesn't mean our memories don't sometimes betray us. And you want to remember that slope is always rise over run. And we can use our slope triangle I already had here. And so that's delta y over delta x. So I can use the values that I already had. Can I help you? You need me? I'm actually recording a video. Okay, so we have a slope is going to be delta y over delta x, and so that slope is going to be 4/7. Now again, you could use the formula that you used back in one of your previous classes, like y2 minus y1, but this is the way I like it. Now, moving a little further, we ask for an equation of the line that goes through that. And it mentions standard form, but I don't start ever with standard form. I always start with point slope because I just find that easier. So if you're not familiar, that's y minus y1 equals m times x minus x1. So when I look at it, the first thing that I noticed is that I need a slope to be 4/7 because I already calculated that right here. That's one of the reasons why you really want to make sure your slope is correct, because you're going to use it over and over again. So I put 4/7 in that place where m is. And I also, because I could choose either value, I chose to use the value 4/8 because I felt like that was easier. Now, the only problem that I have here is it specifically says I want standard form. This is point slope form. So the first thing I did is I distributed this out like this. 4/7 times x and 4 times 4 is 16. Standard form has to be structured where x and y are together on one side of the problem, and the constant is on the far side of the problem. The leading coefficient must be positive, and there can be no fractions. That's like a long list of things that you need. No fractions, the first number has to be positive, and it has to have x and y together equal some value. So I decided to multiply everybody by 7 to bust the fractions up. So that's where I got this line right here, 7y minus 56, and then 4x minus 16. I had to bring the x to the other side because remember it says x and y are together. So when I brought the x across, it became negative. But we have one last problem, and that is this x value has to be positive. So if I multiply through by a -1, I would have positive 4x minus 7 minus -40. And here is where it's actually number 2 that I made a little mistake, but it's on part B, but we'll fix it. Okay, so here we go. I wanted lines that are parallel to JK, but parallel lines always have the same slope. So since this line right here had a slope of 4/7, then my new line needs to have a slope of 4/7. So I went right back to the well with my friend, the point slope formula. I wrote down y minus 5 and x minus -4. Notice the double negative. Again, now this time it said it wanted 2 forms. So I distributed first, and I got closer, but this isn't y equals mx plus b because there's this extra 5. So I added 5 to both sides. So keep in mind, I already had 16 sevenths, and I wanted to add to that 5 to both sides. And that's going to get me 51 sevenths. So I brought that across. That gave me what I needed, 51 sevenths. And then all I had to do is multiply by 7 at Fraction Buster, and that's going to get me to my standard form. Okay, last little question. And that's where I made a mistake because I was thinking we were making it perpendicular to the original line and I wasn't reading my own direction. So I got to be careful. So this problem, I wanted to move it around a little bit to find the slope of this line. And I could see right here, this slope is positive 7/3. But to be perpendicular, then I need to do opposite and reciprocal slopes. And then I will be able to distribute. And just like in the previous question, you're going to be able to use a fraction buster, multiply that out, and get it finished. And when you're all said and done, this is the answer you're going to have, which is y equals -3/7x. When we add the 8 to both sides, we're going to get 68 seconds. And that's our slope-intercept, and we need an ask for both forms right here, so we're good to go. Hey, I will see you guys back in class. Hopefully that was helpful. Bye-bye.